Assalamu alaikum everyone. Hope this video finds you well and safe. Stay safe at home. हालात की मुनासबत से हम ये लेक्चरर जितने भी हैं वो लगे हुए हैं ऑनलाइन कोर्सेज अरेंज करने के लिए ताकि स्टूडेंट्स का टाइम ज़ाया ना हो और स्टूडेंट्स ऑक्यूपाइड रहें अपने कोर्स के साथ मुंसलिक रहें क्योंकि ज़्यादा देर तक डिटैचमेंट भी जो है वो थोड़ा सा इशू बना देती है स्टूडेंट्स के लिए। फिर बाद में क्या कहते हैं कि तवज्जो नहीं पड़ती। पहला लेक्चर जो है ये है फ़िज़िक्स रिलेटेड टू एनेस्थीसिया के सब्जेक्ट से जो फोर्थ सेमेस्टर में पढ़ाया जाता है। तो हमारा जो है होगा इंट्रोडक्शन टू फ़िज़िक्स होगा फर्स्ट ईयर सेकंड ईयर या जो मैट्रिक एफएससी के लेवल की जो आपने स्टडीज़ की होती हैं उसको थोड़ा सा हम रिवाइज़ करेंगे और उनको रिवाइज़ भी करेंगे साथ में, लेकिन उसके साथ जो एनेस्थीसिया में जो इसकी इम्प्लिकेशंस होती हैं वो भी डिस्कस करेंगे कि फ़िज़िक्स का क्या ख़ास रोल है। बीइंग बैचलर्स ऑफ एनेस्थीसिया वी आर कंसिडर्ड टू बी एनेस्थीसिया टेक्नोलॉजी, दैट इज़ अ प्रॉपर टर्म फॉर इट, एनेस्थीसिया टेक्नोलॉजिस्ट। So yeah, in other words we can say anesthesiologist. So we have to study every aspects of it, including how to troubleshoot mechanics machines which are available for anesthesia practitioners, and also some other emergency devices like defibrillators and equipments, how equipment perform, how the flow of care work over there, how how gases are supplied, what is the pressure limiting valves, etc. So everything is in anesthesia is physics. So let's get on with it. Now, outlines basic concepts of physics which are already you have learned in your previous classes like in matric and FSC. Basic concept of physics and anesthesia, we have to relate some things about that. We will discuss that so we can understand why are we studying physics in anesthesia. System international of units, in which I have quoted a lot of units, but those are unnecessary, some of which we will use in anesthesia, so we need to know what they are. So basic concept of physics. First we have to define physics. What is physics? Physics is a natural science that involves the study of matter and its motion through space and time, along with related concepts such as energy and force. By concepts I mean the principles which actually govern the changes of matter and energy and matter, that is defined by Einstein law of conversion of energy जो theory थी उसके मुताबिक की बात हो रही है. So what is matter? As you know, matter is anything that occupies space and have a mass is a matter. And similarly, what is energy? Energy is the factor of it, that matter. So we have to study further ahead how these other physical principles and laws apply on it, on anesthesia and other factors that are related to anesthesia. Now, physics and anesthesia. This was the main objective of the lecture, or we can say the main objective of this subject, which is physics related to anesthesia. Um, as we know, we use in anesthesia we use anesthetic gases, vapors, other gases, including the medical gases we use, that is oxygen, etc. Even we use vacuums for suctioning and other systems. So anesthetic gases, like they are gases, they have to obey some of the principles. We need to know how they obey these laws and how they flow in the pipeline systems, and how can we store them in the cylinders if we are using in a remote. We are in a remote area. We don't have a centralized supply system. We are using we have only access to the cylinders. So how these gases, the quantity of gases in that cylinder, the pressure of the gases in that cylinder, the pressure supplied from the cylinder to the patient should not directly to the patient. It will first will be supplied to the anesthesia machine, and then further ahead into other into the patient's into the patient lungs through ATT, band circuits, everything that has connected patient to the machine and machine to the cylinders. So there will be pressure drop, how to manage those pressure drops, and we use pressure limiting valves for something like that. So to prevent increased influx into the lungs, preventing lung injuries, which is barotraumas, etc. Now, inhalational anesthetics. Inhalational anesthetics are like sevoflurane, isoflurane, halothane. These things are inhalational anesthetics, which are actually vapors are compressed into a chamber, which is actually a vaporizer. They are compressed in that chamber in a liquefied form. They work as they have simple principles of saturation, gas saturations, and other vaporization, evaporations theories. What is vaporization? What is latent heat of vaporization? All these things will be discussed individually in when we discuss the physics of inhalation and anesthetics. Or we just discussed about physics in vaporizer, how the vaporizer perform. There we will study how inhalation and anesthetics are converted into vapors, and they then saturate medical gases or air, and then they are supplied in a saturated form to the patient. Now, gas flow in pipeline systems. Not everywhere we will have pipeline systems that centralized supply of the medical gases, oxygen, carbon dioxide, vacuums, and nitrous oxide, etc. But where we have, like in tertiary care hospital, there are some plants where they supply centralized gas supply to the operation theaters, ICU, or any ventilator where a ventilator is placed. So gas flow is dependent on molecular gas theories, kinetic molecular theory, gas laws. We will discuss those, how gas behave in a pipeline, how gas behave in a chamber, uh, how gases are propelled and their pressure being managed, and next thing will be gas supplies, similarly related to the gas flow in the pipeline system. Again, in gas supplies we will further divide the supply systems like cylinder supply, pipeline supply, and other things. Pressure control and regulator systems are related to the same gas supply system. Medical gas cylinders filling and emptying, pressure limits, volume limits that I already discussed. Now still vaporization for inhalation and anesthetics. In her heat and temperature, how heat and temperature impact vaporization, how atmospheric pressure impact inhalation and anesthetics, Mach value. Fluid dynamics of gas molecules includes turbulent flow, laminar flow, kinetic molecular theory, and other gas laws like George laws, Boyle's laws, Avogadro's, and few more. Now, fluid dynamics is not only about in anesthesia is not only about gases but also about the blood. We will discuss that as well, because there is an impact of blood flow in anesthesia. So we have to know that how blood behave in body. Now, fundamentals of SI units. These are the basic things which we have discussed or have learned in metric and FSC, and so on. We will go with that. Actually, SI represents System International, which is worldwide accepted. 7 basic units, mutually independent of each other. For ease, this we use SI units for the conversion because we have different pressure limits. Like in anesthesia machine, there is almost everything is measured in centimeter of water, which is cmH2O, or few things are measured in mmHg, like blood pressure is measured in mmHg. Some things will be measured in kilopascals or pascals, like gas supplies are pressure measured in kilopascals or pascals. So we need to know which measure is equivalent to how much quantity of the other measure or unit. So for that we need to discuss about derived units and conversion factors as well. Now these are the units which are basic units, derived units, and units not in the SI systems. Now basic SI units are length, mass, time, current, temperature, luminous intensity, and amount of a substance. Now we need to know where these things apply. Now length apply into most of the things as well, which specifically our breathing circuit or the system, the length of the system from where we supply gas to the patient, which includes a path divided between cylinder or central pipeline supply hoses to the anesthesia machine and then to the patient. They also involve some if in length of the breathing circuit is increased, there we will have mechanical dead space in the patient's airway, upper airway, which where there is no gaseous exchange, that has a long length, like heighted peoples heighted people, they will have anatomical dead space. So these factors are needed to be considered. So mass always is will be noted as in body mass index, according to which we advise our specific dosage. हम अपनी जो ड्रग की मकदार होती है मिलीग्राम्स में, या फिर लाइक मैक हम देते हैं, इनहेलेशनल एनेस्थेटिक कितना हमें चाहिए होता है, अदर चीज़ें, बहुत सारी चीज़ें इस चीज़ पे मैटर करती हैं। लाइक बॉडी मास इंडेक्स के लिए स्पेसिफिक जो चीज़ है बॉडी मास इंडेक्स, तो मास हमें ज़रूरी होता है करना। टाइम जो है, टाइम लाइक इन टाइम तो हर चीज़ पे इम्पॉर्टेंट है, एज यू नो टाइम नेवर स्टॉप्स एंड नेवर वेट फॉर अदर, सो वी नीड टू काउंट फॉर दैट, like specifically in inspiratory time, expiratory time, which are fixed in anesthesia machine, that will be discussed in the next few lectures, where we will discuss about physics in anesthesia machine and how to operate anesthesia machine. Now current, amperes. Current are also involved in these things, like in defibrillator. We will discuss about current, voltage, etc. Where we don't want to get too high. In ECG as well, there is also a proper mechanism in which capacitance, amperes, ohms, which is resistance, actually these things are applied. Temperature is important thing as well, like in body temperature, atmospheric temperature, operation room temperature, gases, humidification or warmness, fluid temperature, which if we apply a fluid with low temperature to the patient will have hypothermia, which is not required at the time. Similarly, if too much so not lowest temperature, we need warmers for that to warm our fluid, our blood, so that we can supply that blood or administer that blood or fluid to the patient according to the body temperature. Similarly, we have to keep the environment warm as well in situations. Luminous intensity, candela is its unit. Its importance is specifically in pulse oximeter. This the monitoring devices which actually monitors our vitals by the absorption, by the properties of light, how light is absorbed, different wavelength of lights are absorbed, and on that properties we discuss our vitals, specifically like pulse oximeter. We discuss about our oxygen saturation or sometimes carbon dioxide saturations as well. So amount of a substance is mole, which is applied in Avogadro's laws, that will be applied in vaporizers as well. Now derived units, still temperature, degree Celsius. The SI unit, you need to know the SI unit of temperature is Kelvin, and Celsius or Fahrenheit are the derived units. So force, Newton, pressure, energy, power, frequency, and volume, you need to check these out. Now everything has its own these you see ये टेबल आपको दिख रहा है, ये टेबल जितना भी है इसमें जितनी भी यूनिट्स लिखी हैं, यूनिट्स लिखी हैं या क्वांटिटीज़ लिखी हैं, फिजिकल क्वांटिटीज़, कोई ना कहीं बॉडी में इनका एक्ट ज़रूर होता है, बल्कि कहीं ना कहीं तो हम ले लें इसको आप कि ये तो छोटी सी बात हो जाती है, लेकिन ऑलमोस्ट हर जगह पे इनका असर रसूख है इन सब चीज़ों का। ठीक है, फोर्स देख लें, फोर्स पर यूनिट एरिया की बात हम कर लें, अगर एरिया की बात कर लें तो ये तो प्रेशर पे आ जाएगा, फोर्स पर यूनिट एरिया की बात करें तो प्रेशर हो जाएगी। फिर प्रेशर को पास्कल पर बार में हम भी करते हैं। देखें यूनिट्स ये आप यहाँ पे देख लें, लास्ट जो कॉलम है उसमें देख लें प्रेशर की जिक्र किया गया है, यूनिट्स नॉट इन एसआई सिस्टम, इसको एमएमएचजी में लिखा गया है, सीएमएच2 में लिखा गया है, स्टैंडर्ड एटमॉस्फेयर में लिखा गया है, ठीक है, कैलोरीज में लिखा है, एनर्जी को कैलोरीज में लिखा गया। अब ये दो कैटेगरी ज़्यादातर इस्तेमाल होती हैं। अब एमएमएचजी को हम ब्लड प्रेशर के लिए इस्तेमाल करते हैं, सीएमएच2 को हम आई थिंक कुछ जगहों पे कैपिलरी प्रेशर के लिए भी इस्तेमाल करते हैं, और सिमिलरली एयरवे के प्रेशर में भी सीएमएच2 को इस्तेमाल किया जाता है। एनेस्थीसिया मशीन के अंदर जो हम प्रेशर फिक्स करते हैं या वो वैल्यूज़ हम मेजर करते हैं वो भी सीएमएच2 में होती हैं। ब्लड प्रेशर को कॉन्स्टेंटली ज़्यादातर जो है एमएमएचजी में ही मेजर किया जाता है इंस्टेड ऑफ सीएमएच2, ठीक है। अब नेक्स्ट वी गो फर्दर, ये देखें ये बाकी यूनिट्स हैं, इनकी डेफिनेशन हैं, आप इस चीज़ को भी देख सकते हैं, ठीक है। जैसे यूनिट ऑफ लेंथ को मीटर को डिफाइन किया गया, किलोग्राम, सेकंड, एम्पियर, केल्विन, मोल, कैंडेला, वॉल्यूम, स्पीड, वेलोसिटी, एक्सेलरेशन, ये सब चीज़ें कहीं ना कहीं कुछ चीज़ें इसमें कुछ चीज़ें जो है कहीं ना कहीं मैटर करती हैं। वॉल्यूम तो तकरीबन पूरी बॉडी में हम वॉल्यूम का ऑब्जर्वेशन करते हैं कि बॉडी वॉल्यूम्स कितने हैं, लंग वॉल्यूम कितना है, लंग के अंदर कैपेसिटेंस कितनी है वॉल्यूम स्टोर करने के लिए, जैसे फंक्शनल रेजिडुअल कैपेसिटी आ जाती है वो चीज़ें, ठीक है। ये भी आप ऐसे ही देख लें, इसमें देखें यूनिट्स का जिक्र किया गया है, पास्कल्स क्या चीज़ है, ये रिसेंबल इसका क्या है, प्रेशर के बारे में जिक्र किया जा रहा है। इसकी डिराइव यूनिट जो है न्यूटन मीटर स्क्वायर है, और अगर इसको कंप्लीट हम इसकी एसआई यूनिट्स को ज़ाहिर करें तो हमारे पास किलोग्राम पर सेकंड पर मीटर पर सेकंड स्क्वायर जो है हमारे पास क्या है, इसकी वैल्यू आ जाती है, यूनिट आ जाती है, ठीक है। नेक्स्ट जो है कैपेसिटेंस, उसकी यूनिट्स, सब चीज़ों की ऐसी यूनिट्स आपको मिली हुई हैं। अब need to remember those things, some are not considered like magnetic flux density are not indicated here, inductance in we will discuss that inductance in defibrillator as well, and similarly electric resistance and electric conductance. Capacitance will also be discussed in defib, and electric conductance for ECG and EKG, ECG or EKG or EEG, which is actually electroencephalography. So illuminance, it is not that important, but will be discussed a little bit in when we discuss about physics in the pulse oximeter. Right, we move forward. Now conversion factor, these are important things we need to know and remember that kilopascal is equal to 7.5 mmHg and 1 bar will be equal to 750 mmHg. 1 kilopascal is equal to 10.2 centimeter of H2, and 1 standard atmospheric pressure is equal to 101.325 kilopascals. And 1 calorie, which is actually the food energy, a unit to represent food energy mostly, is 4.18 joule, and 1 kilogram weight is equal to 9.8 Newton. Now pounds per inch square is also used in cylinder supply system, and as well in the central supply system of the gases, medical gases. Atmospheric pressure is 1 pounds, 1 atmospheric pressure will be equal to 14.7 psi. 1 bar will be equal to 100 kilopascals, and atmospheric pressure at sea level, which is atmospheric pressure at the sea level. Now basic concept, pressure. What is pressure? Force per unit area, as you know all. Force per unit area is a pressure. How force per unit area? Each molecule of a gas or liquid apply a specific force on the wall of the container. Now if you measure that force and the area of that container, how much molecules exert force in that, there will have the pressure. Now this pressure in the body is measured in different ways, like a fluid column of mercury or a fluid column of water. Some fluid column of, if we measure it by fluid column of mercury, then it will be measured in mmHg, or if we use a fluid column of water, then it will be measured in centimeter of H2O, but fluid column of mercury is preferred mostly. Analogous meters are also used, but other analogous, I mean the gauge pressure meters, like we use in the BP curve. Now, blood pressure. At What is the importance of pressure? Obviously, the blood pressure, atmospheric pressure, internal lung pressure, other things in the body that exert pressure, their cavities pressure, intracranial, intraocular pressure, everything is related with the pressure. Force is equal to mass into the acceleration, which is kilogram meter per second square. That is equal to Newton. Pressure is equal to force per unit area. 1 Pascal equals 1 Newton acting over 1 meter square. That is the definition of the pressure. A pressure of 1 Pascal will be obtained when a 1 Newton of force acts on 1 meter over 1 meter square area. Unknown pressure against atmospheric pressure known as gauge pressure, used for blood pressure airway measurement as in BP curve. Now there is the relevance, clinical relevance. Fluid to pass out the barrel of the syringe, the same pressure must be developed in the syringe. Now up we need to pass the fluid through the barrel of the syringe. Actually that is our needle. We need to exert a pressure that that will compensate the resistance in that needle. So the needle is a very narrow thing, so it is narrow. It means, according to this formula, if the pressure pressure is equal to force per unit area, area is pressure is inversely proportional to area. If area decreases, it means pressure will increase. Like so, the needle is a very thin, has a very thin lumen. So if it has a thin lumen, it means it has a very less area to pass the fluid through. So if we need to pass the fluid through that barrel, we need to exert the pressure that will compensate this resistance created by that area. Now for a 20 milliliter syringe, another example which I have took from the reference below. For a 20 milliliter syringe, diameter 2 centimeter, pressure generated is 100 kilopascal. Even this is 6 times more than SBP of 16 kilopascals. That is 120 mmHg of the blood, which is blood pressure actually, systolic blood pressure. So during bias block, pressure in the vein during rapid injection can exceed systolic pressure, particularly if a vein adjacent to the cuff is present. So we need to be careful with that. Now another example, take another example. Bed sores. For a 20 kg of a patient, mass supported on an area of a contact of 100 centimeter square is 10 into 10. Force will be 196 Newton. Now 20 kg patient, we have 20 kg patient, multiply it with the gravitational acceleration. As we are discussing about weight, a bed source, it means the force applied will be due to the weight. So 196 Newton weight is this person have, which is 20 kg multiplied by 9.81, that is 196 Newton. Pressure is equal to 90.6 kilopascals. Now pressure, how we calculated that? We will calculate it that 196 divided by 100. We need to convert that into meter square as well. So after that we calculate, we get 19.6 kilopascal. That is greater than 16 kilopascal as discussed earlier here. That SBP of 16, normally we have SBP of 16 kilopascal. So whenever the pressure, external pressure, whatever the source may be of that pressure, exceeds the systolic blood pressure and for a long duration of time, then there will have a risk of ischemia. So bed sores are developed like that. In ICU patients, they are kept there for a long period of time on the same bed, mostly at the same position. So that will, if their weight, if their force, their weight increases the pressure above the systolic blood pressure, there we will have a risk of ischemia. That actually is bed sore at that region, the region which is actually attached to the body and to the bed and are facing downward. Similar concepts are applied for pressure relief valves and expiratory valves of anesthetic breathing systems. Pressure in the circuit exerts a force on the diaphragm, and when this force is greater than that the force exerted by the valve, air escapes through the expiratory valve. They are typically low pressure valves fixed at 50 pascals. Okay, you understand that? Let me repeat that again. Pressure इन द सर्किट। देखें जब प्रेशर लगता है सर्किट एग्जर्ट करती है फोर्स ऑन डायफ्राम पे एग्जर्ट करती है, और अगर जब भी जैसे ही ये फोर्स जो है एक्सीड कर जाती है, एक सर्टन लिमिट को एक्सीड कर जाती है, तो एक्सपायरेटरी वाल्व का एक ख़ास लिमिट होता है, उस लिमिट के बिलो वो ओपन नहीं होता, लेकिन उस लिमिट से अबव अगर प्रेशर एक्सीड कर जाता है तो वो एक्सपायरेटरी वाल्व ओपन हो जाता है और इंस्पायरेटरी वाल्व जो है वो क्लोज़ हो जाता है। तो लंग्स जो हैं वो क्या कहते हैं एक्सपायर करने लग जाते हैं एज अ कंपेंसेशन टू दैट एक्सेसिव प्रेशर टू डिवेलप to save itself, to save the body, to save the lungs from barotrauma. All right. Now volume. Volume is pressure was very little tricky thing, but volume is the simplest one. Now volume is the quantity of three-dimensional spaces occupied by a liquid, solid, or a gas. Common units used to express volume include liters, cubic meters, gallons, milliliters, teaspoons, and ounces. Through many other units exist. Now volume versus mass. What is the difference between volume and a mass? Volume is the amount of space occupied by a substance, while mass is the amount of matter it contains. Now, the amount of mass per unit of a volume is a sample's density, the density of that substance, which we are discussing right now. Like, let's say I have a fluid, let's say water, I have water, a few milliliters of that water. Now, the mass, the volume, there is a difference in between those things. Mass is actually the quantity of that substance with individual molecules in that substance actually, and while the volume is the area or the three-dimensional. Area is actually two-dimensional, but volume is a certain thing, a little bit different. The the three-dimensional space occupied by that substance is actually its volume. All right. Now, what is density? The mass per unit volume. We have a volume. We divide that we divide the mass of that volume on the volume we have is actually the density. मतलब यह है कि हमारे पास एक सब्सटेंस है, एक फ्लूइड है, एक ग्लास में पड़ा हुआ है। अब उस ग्लास का एक ख़ास थ्री डायमेंशनल स्पेस है। इस थ्री डायमेंशनल स्पेस के एक्स, वाई और जी में हम लेंथ मेजर कर लेते हैं। लेंथ मेजर करने के बाद इनको मल्टीप्लाई करके हम वॉल्यूम कैलकुलेट करते हैं। अब जितना थ्री डायमेंशनल स्पेस इस फ्लूइड ने कंटेन किया हुआ है, ये इसका वॉल्यूम है। ठीक है। नेक्स्ट थिंग जो होगी वो क्या होगी, मास की हम बात करेंगे। तो अब फ्लूइड तो है, किस चीज़ से बना, मॉलिक्यूल से बना है। अब एक इंडिविजुअल मॉलिक्यूल का एक्चुअल मास होता है। ठीक है। इन सब को हम कलेक्टिवली हम करें, मल्टीप्लाई कलेक्ट करें और एक ख़ास एक कलेक्टिव मास बना लें, एक कलेक्टिव क्वांटिटी बना लें। इस क्वांटिटी का जो मकदार है, ये अमाउंट ऑफ दैट सब्सटेंस है, अमाउंट ऑफ दैट सब्सटेंस लाइक मोल्स जितने भी हैं, उनका हम वेट कंबाइन करके बनाएं, तो ये इस वॉल्यूम का क्या कहलाएगा, मास कहलाएगा। ठीक है। तो मास इज़ द क्वांटिटी ऑफ दैट matter or amount of that matter it contains. All right. Capacity in relation to volume. What is capacity and what is volume? Capacity is the measure of content of a vessel that holds liquid. ठीक है। कैपेसिटी क्या होती है कि हाउ मच अ क्वांटिटी अ सब्सटेंस अ मटेरियल और अ होल्डर कैन होल्ड, राइट, like grain or other material that take the shape of the container. Like let's say I have a 500 milliliter of flask as shown in this diagram. So this shows actually the maximum volume which it will have. All right, maximum volume which it will have up to the calibrated region. So this is, I think, is actually capacitance. So capacitance is also measured in the lungs, which is lungs as well as heart, vessels capacitance. All right, elastance things. These things are also will also be discussed in upcoming lectures to elaborate properly how things behave in our body in relation to physics. Now, temperature, a simplest thing, the degree or intensity of heat present in a substance or object, especially as expressed according to a comparative scale and shown by a thermometer or perceived by touch. Degree Celsius and Fahrenheit are actually the derived units, while absolute Kelvin is the SI unit, which generally is to be used. But in for body temperature we use Celsius and Fahrenheit, which we have converted from Kelvin. uh, these are the conversion factor. T degree centigrade will be equal to T temperature in Kelvin minus 273.15. ٹھیک ہے. اینڈ فار سیلسیس اگر ٹو فارن ہائٹ، اگر سیلسیس کو فارن ہائٹ میں کنورٹ کرنا ہے تو ایسے کریں گے کہ 1.8 کو ہم یا پھر 9/5 کو 1.8 یا پھر 9/5 کو ہم ملٹیپلائی کریں گے فارن ہائٹ کے ساتھ، اور جو اس کو ایڈ کریں گے 32 کے ساتھ. آل رائٹ. سیلسیس کو فارن ہائٹ میں کنورٹ کرنا ہے نا، تو اٹ مینس کہ ہمیں فارن ہائٹ سیلسیس نون ہے، فارن ہائٹ ان نون ہے، تو فارن ہائٹ ول بی ایکول ٹو سیلسیس ملٹیپلائڈ بائی 1.8 یا پھر 9/5، اور اس کو سیلسیس کو ملٹیپلائی کرنے کے بعد اس کو ہم 32 کے ساتھ کیا کر لیں گے، ایڈ کر لیں گے. ٹھیک ہے. ہاں، یہ آپ کے لیے ریفرنسز ہیں، آپ اس سے دیکھ سکتے ہیں. اینڈ تھینک یو.